I'm Anil Kumar, sharing with you 11 questions from previous test papers. This video is for my student Anna, and I hope she gets similar questions and performs very well in her exam. This paper may also help many students who are busy in so many activities, including prom these days. I wish they can watch half of my video and pass with good marks. So let's look into these questions. You may actually pause the video, copy the questions, solve them, and then check my solutions. Question number 1. Determine equivalent expression for minus cos x plus pi by 2. Question number 2. Determine equivalent expression for sine 5 pi by 16. Question 3. Find exact value of sine 75 degrees plus sine 15 degrees. Remember, this test paper is without calculator. Okay, that's kind of important. Question number 4. Express sine 2x in terms of tan x. 5. Express sine 2x divided by 1 minus cos 2x in terms of tan x. Question 6. Given sine square x equals to 8 over 9, x between pi by 2 and pi, quadrant 2 that is, determine sine 2x and cos x by 2. So we're going to use double angle and half angle formulas extensively. Question 7. Determine the value of tan 2 theta when sine theta equals to minus 4 over 5, theta is between 3 pi by 2 and 2 pi. Determine the value of sine 2x in the following equation. 2 tan x minus tan 2x plus sine 2x equals to 1 minus tan 2x tan square x. You need to find tan sine 2x, right? Push this paper a bit so that you can see question 9 to 11, right? So here are the rest of the questions, right? So let me read these questions again. Question 9 is determine exact value of cos minus 5 pi by 12 and sine 13 pi by 12. Question 10 is if sine x equals to 8 over 17, x is between pi by 2 and pi, sine y equals to minus 21 over 29, x between 3 pi by 2 and 2 pi, evaluate tan x minus y. The last question here is develop a formula for tan a plus b plus c. So I hope you have already copied the questions. Try them out. Time limit is an hour, and then watch my video. Thanks for your time. Question number 1. Determine equivalent expression for minus cos x plus pi by 2. Now there are two ways to do it. One is shortcut. Let me teach you the shortcut method. The other one is a standard method. We are talking about minus cos x pi by 2. So let's write down this expression. We have minus cos x plus pi by 2. So that means we have, let's say we have an acute angle x, right? So this is the acute angle x. Now when I say x plus pi by 2, what do I mean? X plus pi by 2 means that we have something like this, right? So now the angle is x plus pi by 2. Now since you are in quadrant 2, we know that cos is going to be negative, right? So as you know, all are positive in quadrant 1, sine is positive in quadrant 2, tan in 3, cosine in 4. So we know we'll keep this minus as such, right? And look at this expression, cos, let me write down here, minus. Now we're looking at cos x plus pi by 2. It is in quadrant 2, it is going to be negative, right? Now as far as the triangle is concerned, it has been rotated by pi by 2. So cos becomes sine, so we get sine x. And minus minus becomes plus, so you could write this as plus sine x. So from the diagram, that is absolutely clear. Now some of you will spend a lot of time in using compound angle and get to this result. Let me show you how you're going to do it if you do it that way, right? So you'll expand this using cos a plus b formula. We'll keep this minus. Let me make a square bracket. So we have cos of x, cos of pi by 2 minus sine of x, sine of pi by 2. That's the formula cos a plus b. And as you know, cos of pi by 2 is 0, right? So we have cos x times 0 here, and sine of pi by 2 is 1, so we have minus sine x, and then this part is 0, so let me write 0 here. We have minus sine x, and when you open this bracket, you get plus sine x. So the result is exactly same. So when you're going for compound angle formula, you can definitely use the formula which, as you must have applied, cos a plus b is cos a cos b minus sine a sine b, right? So I hope that is clear. So I'm taking this opportunity to also review the concepts of compound angle. Second question here is, determine equivalent expression for sine 5 pi by 6. So let's look into this concept also. 5 pi by 6 means what? Basically, we have divided this pi into, 16, not 6, 16. So we have divided this pi into 16 portions. So this is 16 pi by 16. That is equal to pi, correct? So 5 pi by 6, this is 8, right? This is 8 pi by 16. So 5 will be somewhere here, right? So that becomes 5 pi by 16. Now when we are looking for equivalent expression, the acute angle remains kind of same. We can look into a position like this, where this acute angle is also 5 pi by 6. In that case, we get equivalent expression for sine, since we know that sine is positive in quadrant 2, right? In quadrant 2, sine is positive, and therefore I could write sine 5 pi by 6 as also equal to 5 less than 16, right? 5 less than 16, which is sine 11 pi by, 16, I'm sorry. 11 pi by 16, right? Now, you could also write equivalent expressions of 5 pi by 6 when you can go like this to the same point, right? So in that case, it will be sine of minus. So when you go like this, the angle is negative. Total angle here is 32, right? So it is 32 pi by 16. So if you take away 5, that is to say 32 pi minus 5 pi over 16 can give you the answer, right? So this negative is for the negative angle, and sine of negative is negative, right? So we could also get sine of minus 27 pi by 16, which could be written as minus sine 27 pi by 16, right? So I hope you get it right. Well, there could be many other solutions. You could also write different answers for this, extending this line to other quadrants, and that angle could give you minus. Here sine is negative, so you can also write this as minus sine. If I add 5 to 16, I get 21 pi by 16. That could also be a solution, right? So as you can see, we could actually give many answers to this. And here also we have a solution. So I could also write this as minus sine 5 less than 32, which is 27, right? So we can write this as minus 27 pi by 16. So effectively 5 pi by 16 could be written as 11 pi by 16 minus 27 pi by 16, 21 pi by 16. So there are many ways in which it could be written. I hope the concept is absolutely clear. Well, the best answer is the first one which we gave here, right? Okay, let's move on to question number 13. Now here we need to find exact value of sine 75 plus sine 15 degrees. Now this is a thinking question. Here we can apply a very special formula which I hope you remember. We have sine c. We have sum to product, right? Sine c plus sine d is equals to 2 times sine a cos b, where a is sum of c and d divided by 2 and b is difference of c and d divided by 2. So that is the formula which converts sum to product, right? So you're looking to sum to product formula which can be applied to get this result, right? So let's apply this formula here. We are given sine of 75 degrees plus sine of 15 degrees, which could be written as, let me write 2 first. 2 sine of 75 plus 15 divided by 2 times cos 75 minus 15 divided by 2, right? All are in degrees. So that gives you twice sine, and 75 plus 15 is 90. So we get 90 degrees by 2. Cos of minus will give you 60 degrees over 2. So that gives you twice sine of 45 degrees, cos of 30 degrees, correct? And you can use special triangles. Let me make them here. 2 of them. Okay. So let's say this is, we're looking for 30. So that is pi by 6, which is 30. So we get 1, 2 square root 3. And this is pi by 4. Square root 2, and 2, correct? So that, placing the values here, we get 2. Sine of 45 or pi by 4 is square root 2 over 2 times cos of 30 degrees, looking from here, will be square root 3 over 2, right? Square root 3 over 2, 2 and 2 cancel, and what we get here is square root 6 over 2 as our answer, right? So that is direct application of sum to product. It's a very, very important formula. Look into its derivation also. I'll provide you with a link. Now let's look into question number 4. Question number 4. Express sine 2x in terms of tan x. Now this is a very difficult question. Let's try to see how to do it. So we need to write sine 2x in terms of tan x. We know from double angle formula sine 2x is 2 sine x cos x, correct? Now how do we get from sine to tan? We can look into it like this. Tan x is ratio of sine x and cos x, correct? So we could write sine x as cos x times tan x, correct? So let's do that. So we are writing sine x as cos x times tan x. So this will now be 2 times sine x as cos x times tan x, and we already have cos x here. So basically we have 2 cos square x times tan x. Now how to get rid of cos x? Well, as you know, 1 plus tan square x is actually equals to secant square x. But secant square x is reciprocal of cos, right? So we could write this as cos square x. So we get 1 plus tan square x as 1 over cos square x. So what is cos square x? In terms of tan, it could be written as 1 over 1 plus tan square x. Do you see how much of your knowledge goes into this particular derivation? So we'll replace cos square x by this expression. So we get 2 times 1 over 1 plus tan square x, and we already have tan x here. So we have got all terms in tan, so now I can write sine 2x as equals to 2 tan x divided by 1 plus tan square x, correct? So that is how you could do it. Now, as an additional question, let's say question 4b, your duty is to check out what is cos 2x in terms of tan x, correct? So let this be an exercise for you. I hope you're finding it interesting and useful. Question number 5 here is, we need to now express sine 2x over 1 minus cos 2x in terms of tan x. Okay, let's see this. Sine 2x over 1 minus cos 2x. Now, we want tan x, right? So, we could write sine 2x as 2 sine x cos x as we did earlier. Okay, 2 sine x cos x. And cos 2x could be written as 1 minus 2 cos square x minus 1. Let's put it in bracket. Is that clear to you? Well, you did this formula like cos a plus b is cos a cos b minus sine a sine b, right? If I write b equals to a, I get cos of a plus a equals to cos a minus sine a, correct? Or I can say cos of 2a equals to cos square a minus sine square a. And to get everything in cos, I could actually write, now this is an important formula, sine square a as 1 minus cos square a. And that gives you 2 cos square a minus 1, correct? So cos 2a could be also written as 2 cos square a minus 1. Okay, so these are important formulas which we are going to use in our test paper. You could also from here get, if you write cos square a as 1 minus sine square a, you get cos 2a as 1 minus 2 sine square a, right? So that's another important formula which we are going to apply. So I hope all these things are clear to you. Let's continue. So we have 2 sine x cos x in the numerator, and denominator, if I open, I get 1 minus 2 cos square x, and that becomes plus 1. So basically we get 2 common, right? So we get 2 common. So we have 2 sine x cos x over, we can take 2 common and we get 1 minus 2 cos square x, correct? Now at this stage, when you get 1 minus 2 1 minus cos square x, I actually ran out of space, but anyway, we are very close to the result. 1 minus cos square a, 2 is common, so this 2 is also taken common. So now 1 minus cos square a, as you know, is sine square x, right? So we could write this as 2 sine x cos x. I'm moving to right, I don't have space here. 2 times sine square x, correct? So at this stage you can cancel the common 2's here, okay? So we'll cancel these 2's, and one of the cosine gets cancelled. So what you get here is cos x over sine x, which is cot x. So we could write this in terms of tan as 1 over tan, right? So cot is 1 over tan. So we can write this expression as 1 over tan x. Is that clear? And now what I've done here is changed your question a bit, right? So you'll understand why I'm getting slightly different answer than what you expected. So I flipped the numerator and denominator, and that's what you get, okay? Question number 6. Given sine square x equals to 8 over 9, x is between pi by 2 and pi, determine sine 2x and cos x by 2. Now we are entering into half angle and double angle formulas. We are given that the x value is between pi by 2 and pi. That means we are in quadrant 2. So in quadrant 2, only sine is positive, right? So in quadrant 2, sine is positive. As you know, all are positive in 1, tan in 3, and cos in 4. So what we are given here is sine square x is equals to 8 over 9. So that means sine x is equals to square root of 8 over 9. So that gives you, whenever you do square root, it is positive and negative. However, since we are in quadrant 2, and therefore we are taking positive value. So 8 could be written as 4 times 2 in the square root part, and square root of 9 is 3. So we could write this as 2 square root 2 over 3. So that is the value of sine x. When you know sine x, we can also find cos x from here. Well, let's use sine square x. So we know cos square x is equals to 1 minus sine square x, correct? That means 1 minus 8 over 9, and that means 9 minus 8 over 9. So you can say that cos x is equals to, which is 1 over 9. So cos x is 1 over 3, right? Square root of this. Since we are in second quadrant, we are going to take negative value. Is that clear to you, right? So that is how we should be doing it. Now, we know sine x and cos x values. They should help us to find the value of, I actually skipped a step here. Let me rewrite that step. We could write cos x as square root of this. Is it okay? And since we are in quadrant 2, we take negative value. Is it clear? And so we get this part. Okay. Now we need to find what sine 2x is. So sine 2x could be written as 2 times sine x cos x. So that means 2 times sine x is 2 square root 2 over 3, and cos x is negative 1 over 3, right? So 2 times 2 is 4, negative value because of this, square root 2 over 9. So that becomes the value of sine 2x. So this answer is negative 4 square root 2 over 9. So that is sine 2x. Now how do we find cos 2x? I mean cos half x. So we need to use half angle formula. Some of you may not remember, but let's derive it. So we know what is cos 2x. Let's start from here. Cos 2x is 2 cos square x minus 1. Rearranging, we get 2 cos square x equals to 1 plus cos 2x, right? We are taking this 1 to the side, and so we get this. So that is cos square x is equals to 1 plus cos 2x divided by 2. And we can write cos x as equals to plus minus square root of 1 plus cos 2x over 2. We could also write the same thing in x by 2. So we could write cos x by 2 equals to plus minus square root of 1 plus cos x over 2. Right? So instead of 2x, if I write x, this becomes half x. So that is your half x formula. So now we can actually write down the exact value. So we have the formula as cos x by 2 equals to, now if cos x is in this quadrant 1, cos x by 2 should be in which quadrant? So now we are in quadrant 1, right? Since x by 2 will be here, right? This is x by 2. So we'll take positive value. So we have positive value 1 plus cos x over 2, which is square root of 1 plus cos x is minus 1 over 3 over 2. Now here we could take common denominator of 3. So we get 3 minus 1, right, square root, and everything over 2, correct? So that gives you 2 over, this gives you square root of 2 over, so we'll bring 3 down, so we get 2 times 3, 2 and 2 cancel, so we get square root of 1 over 3. Now, it is always a good practice to rationalize, so I'll actually multiply and divide by square root 3 here. So if you do that, we can write this answer as square root 3 over 3, correct? So that becomes this answer. So square root 3 over 3 is your cos x by 2. So I hope that is absolutely clear, right? Now let's move on to question number 7. Question number 7 is, determine the value of tan 2 theta when sine theta is given to us, and we are now in quadrant 3 pi by 2 and this. So we are now in quadrant 4, right? Sine theta is negative, makes sense. Okay, so let's write down. We know sine theta is equal to minus 4 over 5, and theta is between 3 pi by 2 and 2 pi, right? 2 pi. That is to say, we are in quadrant 4. In quadrant 4, only cos is positive, all others are negative. Sine value is negative as given to you. Okay, now we need to find what tan 2 theta is. Tan 2 theta, we can straight apply the formula, which is 2 tan theta plus tan theta, which gives us 2 tan theta over 1 minus tan square theta, correct? Now to find the value of tan theta, what we can do is, we can consider a triangle where, let's consider angle to be an acute angle, theta. So the sides are 4 over 5. So this is 4, this is 5. So that is going to be 5 square minus 4 square. We know that is 3. So from here, we know what tan theta is. Tan theta is basically 4 over 3, right? Since you are in quadrant 4, it has to be negative. Do you see that? So what we do is that we take up positive values and then put the final value based on the quadrant. So that's the value for tan theta. So tan 2 theta could now be written as 2 times minus 4 over 3 over 1 minus 4 over 3 whole square. See, let me write minus. It becomes positive, of course. So that gives you minus 8 over 3 for this numerator. And this portion, we could write this as, let me write here, 1. Now here, minus becomes positive. So we have 1 minus 16 over 9, correct? So let's work with it. So we get minus 8 over 3 times. This 9 goes in the numerator, gets multiplied here. So we get 9 minus 16, correct? Now, so we have minus 8 over 3 times 9 over 9 minus 16 is negative, and 16 when you take away, that would be 7, right? So we get 7 here. So it could be simplified a bit. We can actually cancel factor this 3, right? So we could go 3 times, and therefore we could write this answer as negative makes it positive. 8 times 3 is 24 over 7. So 24 over 7 is the value of tan 2 theta. So tan 2 theta is 24 over 7. Let's see question number 8. We are almost halfway through. Question number 8. Determine the value for sine 2x in the following equation. 2 tan x minus tan 2x plus sine 2x equals to 1 minus tan 2x tan square x. So we will just rearrange and find what sine 2x is. Sine 2x can now be written as, we have 1 minus tan 2x tan square x, taking all these terms to the right side now, minus 2 tan x plus tan 2x, right? So we have taken all the terms. Now rearrange. Tan 2x can be written, well, we can combine these two. So let me write this as 1 minus 2 tan x. So I'm just switching their position, right? So, and then we have minus tan 2x tan square x plus tan 2x. So we have 1 minus 2 tan x. We can take tan 2x common. That was the whole idea, to just switch them. So we have tan square x minus 1. Right? Now tan 2x could be written as ratio of tan 2x is 2 tan x over 1 minus tan square x, using the double angle formula. And the numerator we have tan square x minus 1. Now that goes minus 1 times, right? So if I cancel these two, it gets minus 1 times, right? So minus minus makes it plus. So I could write this as 1 minus 2 tan x plus 2 tan x. Now that is 0, so we get 1. And therefore, we find the value of sine 2x. You don't really have to find x. You need to only find what is sine 2x, right? So what we get here is that sine 2x is equals to 1, correct? We are not finding x, remember that. If the question was to find x, if the question was to find x, then of course the sine wave is kind of like this, right? And it is 1 for pi by 2. So in that case, you could write 2x equals to pi by 2 or x equals to pi by 4, right? But the question is just this. Okay, let's move on to question number 9. Question number 9. Determine exact value of cos 13 pi by 12 and sine 13 pi by 24. So I changed this question a bit. So we'll take up double angle formula and half angle formula both together. So we'll extensively use half angle formula. Let me write down the formulas here. We derived formula for cos x by 2 earlier. So cos x by 2 could be written as plus minus square root of 1 plus cos x over 2. You could follow same steps to derive sine x by 2 formula also, but you could use it directly, right? So 1 minus cos x by 2. So these are the formulas to be used. Now since we are talking about 13 pi by 12, let us see in which quadrant we are, and then we'll work it out. 13 pi by 12 means the pi is divided into 12 parts. So this is 12 pi by 12. So 13 will be right there, right? So basically, we are in quadrant 3. And in quadrant 3, we are expecting a negative answer. The acute angle here is pi by 12. So the acute angle here is pi by 12. So I could write cos 13 pi by 12 as equal to, since we are in quadrant 3, this value is negative. So we write this as negative cos of pi by 12. So I hope this step is absolutely clear. You don't have to split it into, and then work out with compound angle. This is a better strategy. So now pi by 12 is half of pi by 6. So we know, let's make this triangle, pi by 6 triangle, which basically is pi by 3, pi by 6, square root 3, 2, and 1. And we know cos of pi by 6 is basically square root 3 over 2, right? Applying this formula, we can write down that, so we have to now figure out what is minus cos pi by 12. Is it okay? So let me just draw a line here. So we'll now figure out what is minus cos pi by 12. So that is x by 2, x becomes pi by 6, correct? So it is equal to square root of 1 plus cos pi by 6 over 2 square root. Now since we are working in pi by 6, 1 pi by 12 is basically, now this minus, so we are keeping minus, but that part is positive. Is that clear to you? Right, that's the acute angle. So we get minus square root of 1 plus cos pi by 6 is square root 3 over 2. And then we have 2 in the denominator. Now that gives us the value of minus. That 2 comes in the denominator giving us 4, and we get 2 plus square root 3. Correct? And that becomes the answer. 2 can be written outside, so we have minus half square root of 2 plus square root 3. So that is the value for cos 13 pi by 12. Is that clear? Now we need to find what is sine 13 pi by 12. Right? So for that we will use the other formula. So we can say sine 13 pi by 24, it is, right? 24 will be equal to. So if x is now 13 pi by 12, so we'll use this value, right? 13 pi by 12. So that gives you minus. So 13 pi by 12, you are actually in which quadrant? That is a positive value. Within square root, let me write down here first. Okay, that space, or we'll write like this. 13 pi by 12, that means we are in quadrant 1. And 13 pi by 24, which will be equal to plus, because we are in quadrant 1, square root of, we are going to use this formula, 1 minus cos 13 pi by 12 over 2, right? That formula. So what we are saying here is that x is equals to 13 pi by 12 and x by 2 is equals to 13 pi by 24, right? So that is how we are now using this particular formula of sine x by 2. So I hope that point is clear. And what is 13 pi by 12 cos 13 pi by 12 equals to? We found that cos 13 pi by 12 is this, right? So we know cos 13 pi by 12 is equal to this value, which is minus half square root of 2 plus square root 3. Do you see that? So that value is going to be utilized. So using this value, we get square root of positive is outside. Now this is negative, so that negative makes this as negative. So we could write this as 1 plus, right? Making this negative. And here we have square root of 2 plus square root 3 and everything over 2. This is half, right? Over 2. And then we again have half here. So let me write like this. Times half. Is that okay? Times half. So 2 times 2 within square root becomes 4. So I'll bring it out. And within this square root, because I have to multiply this by 2, I get 2 plus square root of 2 plus square root 3. Do you see that? Is that clear to you, right? So within square root, I took common denominator of 2. So it became 2 plus all this. And 2 times 2 is 4, so square root of 4 is 2, so that is what we get, right? So we could write here that sine 13 pi by 24 is equals to half within square root 2 plus square root 2 plus square root 3. So that becomes the answer, right? So it is kind of tricky, but I hope you understand and appreciate it. Question number 10. We are given sine x as 8 over 17 and x is between pi by 2 and pi. So what we're talking about here is that we have x in quadrant 2, right? So this is the value of x. X is in quadrant 2. This is x, okay. The other value is y, and y is in quadrant 4, 3 pi by 2 and 2 pi. That means quadrant 4, right? This is quadrant 4. So let's say the y value is somewhere here. So this is y in quadrant 4. It's important to understand this because now we can give all values to sine and cosine. So what we know from here, that sine x is equals to 8 over 17. It is positive here. So if sine x is 8 over 17, in that case, what is cos x? So we know hypotenuse is 17, right? So 17 square minus 8 square, square root is actually equal to 15, right? So this particular makes a triangle here. So let me make this triangle for x. Sine x is 8 over 17. So this position here is 15. So from here, you know what tan x is. Now, since you are in quadrant 2, tan has to be negative, correct? So we can write from here that tan x is equal to 8 over 15 with a negative value because of this. Is it okay? Now, let's look into sine y. Sine y is equals to minus 21 over 29, correct? So basically, now we are looking into this triangle, and let's say acute angle will give us 21 over 29. So what is this side? We can calculate this side as 29 square minus 21 square, and then we'll square root it, right, which is 20. Answer, which is 20. So this is 20. Okay. Now some of you may remember these square roots or can do it with alternate methods. Otherwise, as an exception, you can use this triangle, right? So from here, we know what tan y is equal to. Since you are in quadrant 3, tan y is also negative. So we'll write this as negative 21 over 20. Is that clear? So we know what tan x is, we know what tan y is, and now we can find what is tan x minus y by application of straight formula. So which is tan x minus tan y over 1 minus 1 plus tan x tan y. Correct? So you could substitute these values, which is equal to tan x is minus 8 over 15. That minus minus becomes positive 21 over 20. And here we get 1 plus. Product of these two negatives will remain positive. So we got 8 times 21 over 15 times 20. Now 15 times 20, you can multiply both numerator and denominator. So in the numerator, we get minus 8 times 20 plus 21 times 15. And the denominator, you get 15 times 20 plus 8 times 21. Okay. Now this question is exception, where I think you may be allowed the calculator, right? So taking the liberty of using the calculator now. This may take time. So we'll do 21 times 15, take away 20 times 8 in the numerator, which is 155, divided by 15 times 20 plus 8 times 21, which is equals to 468, and you can divide 155 by 468 to get your final answer, which is 0.33, right? So that is how you could actually solve this question, right? So let's move on. We used calculator in one of our questions. It was not really allowed. So let's take a penalty of 0.5. Move on. Here is the last question. we need to develop a formula for tan A plus B plus C, right? So that should not be difficult. We can treat A plus B as one term to begin with. So we could say tan A plus B plus C, treating A plus B as 1. So we could write this as tan A plus B plus tan C, right, over 1 minus product of these two, so tan A plus B times tan C, correct? Now we'll again apply the tan A plus B formula, and so we can write this as, you need more space, so tan A plus tan B over 1 minus tan A tan B plus tan C over 1 minus, so we'll expand this, tan A plus tan B over 1 minus tan A tan B times tan C. Tan C. Since these denominators, we could multiply all the terms, so we get tan A plus tan B plus tan C times the denominator part, which is 1 minus tan A tan B, right? And in the denominator also, we can take this as a common factor, 1 minus tan A tan B. And here we have minus product of these two, which is tan A plus tan B times tan C, correct? So we got all tan terms. Now we can just expand and simplify. So in the numerator we have terms like tan A plus tan B plus tan C. That is expanding, we'll multiply both, right, with this and this. So we get minus tan A tan B tan C, correct? And in the denominator we have multiplying it here, we had all this, so 1 minus, let's rewrite, so 1 minus tan A tan B, open the bracket, multiply by tan C, so we have minus tan A tan C, and then we have minus tan B tan C, correct? So that becomes the formula for tan A plus B plus C, right? I hope you learn all these steps, and I wish you all the best. So that's the end of it. We solved all these 11 questions as you had seen earlier. One of these questions I changed in between, and that was I changed this to plus 13 pi by 12 so that we save time and use double angle formula. So I wanted to highlight this change before closing. So I hope it is absolutely clear how this test paper can be easily done without calculator. In fact, we did use calculator in one of our questions, which was question number 10. But apart from this, it could be done without any calculator. I wish you all the best. Hope you enjoyed the solution of this particular test paper, rather lengthy. If you like and subscribe to my videos, that'll be great. Thank you and all the best.